Okay, today I'm going to talk to you about the state space form of the differential equations using the block diagram method. So in here I have outlined two steps in here that we need to do first, that you are familiar with, and that is to draw a free body diagram and then to derive the equations in second order form. So let's take those two steps first, and then I will outline the next objective, which is to get the state space form. So in preparation to this, the first thing we're going to do is to make a little drawing here of this and do a free body diagram, and just put it in there. And let's just do it for the first mass in here, and get the free body diagram going in here. I'm just going to use red pen for this. In here you are going to have the force, which would be m1g, the gravity force in here. We are moving up for x1, so this is the positive direction, up like this for x1 and x2. If that's true, this spring is going to pull it back in here, and you're going to have a force that says k sub 1 that multiplies x1 minus x2. And on this other one, you're going to have also a b sub 1 that multiplies x1 dot minus x2 dot, like that. So this is the free body diagram for this first mass. What we need to do in doing the derivation of the equation is to keep in mind that the summation of the external forces equals to mass times the acceleration of that mass. Okay, so that's where we start. So having done this, let's just go here and do exactly what we just said. Summation of the forces equals to mass times acceleration. So I would say this would be a minus k sub 1 times x sub 1 minus x sub 2, like this, minus v sub 1 times x sub 1 dot minus x sub 2 dot, and minus m1g, like this, should be equal to m1x1 double dot, like that, right? So that is my first differential equation that I have. I think this is my preferred form also when you're doing simulating block diagrams from these equations. So consistent with that idea, let's just leave this equation in this form for now. You're going to see later on that we're going to need the value of x1 double dot as alone, but for now let's just keep it like this. Okay, so I'm just going to do it for the second one. So in here we have the second mass in here, like that, and we need to move it down a little bit so that we have a space to do things. And let's just do consistent with the same colors in here, and this would be of course this is going to be m sub 2 times g, right? And then these forces acting on this mass will act in the opposite direction. So this would be the k sub 1 times x sub 1 minus x sub 2 over here, and on this side you're going to have the other one, which would be b sub 1 times x sub 1 dot minus x sub 2 dot, but now in the positive direction as opposed to the negative direction. But this on this is going to have one that pulls it, and this is k sub 2 times x sub 2, like that. So I need to fulfill my second step for this one. So I am going to go back in here and I say, okay, this is my forces are k sub 1 times x sub 1 minus x sub 2, like this, and then plus, in this case, v sub 1 times x sub 1 dot minus x sub 2 dot, like that, and then minus m sub 2 times g and minus k sub 2 times x sub 2. This is going to be m sub 2 times x sub 2 double dot, like that. Okay, so now I have derived the two equations in second order form. I did my free body diagram. Everything is cool so far. So in here, I go here, and then I'm going to outline step number 3. Step number 3, I'm going to say convert, because state space form is only first order form equations. We need to convert the second order differential equations into a set of first order differential equations. Okay, I may say, what do we need to do for this? To do this, we need a variable, coordinate transformation, or variables transformation, and we need to specify what that transformation is. Okay, so let me see, I'm going to move this a little bit so my letters don't interfere with my drawings. So there we go. Now, so let's just outline here as if these are our objectives, So we're going to say here we're going to say transform to first order equations. Okay, how do we do this? What we need is a coordinate transformation. Ultimately, we want that dy1 dx, dt equals to something. We need this form, dy sub 2, because we have two second order differential equations. We will end up with 4 first order differential equations. This is what we need to find. Yeah? Okay. How do we do this transformation? What we need to do is, the first variable that changes is that I would say that x sub 1 is equal to y1, and that dy1 dt is equal to y sub 2. But remember, we need dy1, then we need this 2. We need that dy sub 2 dt is equal to what? This will be d squared y1 dt squared, which is this is equal to x1 double dot, right? Okay. We also need another transformation that x2 is equal to y sub 3, and dy sub 3 dt is equal to y sub 4, and that the other transformation is that dy sub 4 dt is equal to d squared y sub 3 dt squared, and this of course is x sub 2 double dot, like that. So things look much hopeful right now, because right now you see, instead of having these two differential equations in second order, I am going to have 4 first order equations. So this one is basically in the form that we want. You know, this equation is this one right here, and so is this one, but we need to work on this too. But you see, what I want to say right now is that this we know, and so do we this one. See, so we know this and this. So I think our system of equations can be rewritten with this knowledge on hand, that x1 double dot is 1 over m1 times the whole thing on the left, right? So I am thinking that we could begin writing our form already and using the equations up there. So well, let's give it a shot. So this dy1 dt is equal to y sub 2, and that dy sub 2 dt is equal to 1 over m1, this is x1 dot, 1 over k, you know, here's this term, 1 over m1 that multiplies this, that says k times x1 minus x sub 2. I think this was a minus sign, wasn't it? Am I correct on the, yeah. Then minus b1 minus from here, see, b sub 1 for x sub 1 dot minus x sub 2 dot, like that, minus m1g, yeah, that's it. And then we'll close these brackets like this. So you see, this is an issue here, that this would be easy to modify. So it would be a form that you can modify. Minus k sub 1. What is x1? Is y1, right? What is x2? Is y3. And then you have minus b sub 1. What's x1 dot? X1 dot is this one. X1 dot is y2 in here. And then what's x sub 2 dot? X sub 2 dot is y sub 4, see? Because y sub 4 is dy sub 3 dt, in other words dx2 dt. So this would be minus y sub 4. And then you have minus m1g like this. Okay? And then you have this equation, dy sub 3 dt is equal to what? Y sub 4. And the other one is that dy sub 4 dt is equal to for this one, see, k1 minus x sub 1 minus x sub 2, this would be 1 over m sub 2 times k sub 1 times x1 minus x sub 2 plus b sub 1 times x sub 1 dot x sub 2 dot, like that. See that? Those two terms I copied it from here. Yeah. And then minus m2g minus m2g and what? Minus k2 minus k sub 2 times y sub 3. Okay. Minus k sub 2. I'm just going to write it down as it is. X sub 2. Yeah. But you could, this is going to be 1 over m sub 2 times k sub 1 times, this is y1 minus y sub 3. Yeah, right there. Plus b sub 1 for y1 dot is y sub 2, and the y sub 4 dot is y sub 3, because that is this y sub 2 minus, excuse me, y sub 4 is the one that so y sub 4 is, yeah, minus y sub 4. Okay, and then I still have this terms, minus m sub 2 times g minus k sub 2, what's x sub 2 is y sub 3. See? Now I am prepared to write these equations into matrix form. I'm going to change the color now so as to emphasize that a little bit. And here what we are interested is, we're interested in writing the form that, well, yeah, I'll do it here. X dot is equal to a times the vector x plus d that's the vector of inputs. This is what we want from these equations. But you can see that pretty close, we are pretty close to it right now. So I need to make a vector in here of the derivatives, where the first derivative is dy1 dt, the second one is dy sub 2 dt, this is dy sub 3 dt, and then of course dy sub 4 dt. There we go. Yeah, see, there we go. And then you have to multiply this matrix by y1, y2, y3, and y sub 4 plus and then the inputs in this case minus m1g and the other one was also m sub 2 times g. Later on we put the minus sign where it belongs to. So let's just fill this in and actually draw it with another pen in here. Let's just do the first one, the first equation that says y1 equals to y sub 2. If that's true, this is a 0. This is going to be a 1 for the second one. 0, 0. And then you have two zeros over here because there are two sources. Okay, now for the second one, for this equation, the value of y1 is minus k sub 1 over m sub 1. The value of y sub 2 is minus b sub 1 over f sub 1. Yeah. And then, okay. And then you have y3 and y sub 4. This would be plus k sub 1 divided, because minus minus plus, and then this other one on the side, this is okay, for y sub 4 is plus b over 1 b1, yeah, over m1. So this is going to be kb so we have done all b sub 1 over m sub 1 is what we have. And then this one is going to have a minus 1 over here and a 0 because of this. And now on the other one, y sub 3 is y sub 4, so this is going to be like this, and this will be a 1. Okay, and then of course this would be a 0, 0. And then you have in here this y sub 4 from this equation. For y1, what do we have? K sub 1 over m sub 2. Okay, and then you have, okay, here we need to close these brackets, guys. 1 over m sub 2 for y sub 2 would be b1 over m sub 2. b1 over m sub 2. That is the second one. But I believe on the third we have several contributions. On the third we have minus okay, this 1 and 2 and 3 has got 2 of them in here, so we're gonna have to do this, k1 over m sub 2 we are on the third, k1 over m sub 2 minus k2 over m sub 2. And then we have finally one more term which is in the y sub 4, which would be m sub 2 b over m sub 2. Wait a second. We need the 1 b sub 1 over m sub 2. And then in here you're gonna have a 0 for the first and a minus 1 over here. Now we have this x dot is equal to this matrix A times this vector x like this, plus this matrix U, that's the vector. So and this is the state space form. This obviously is the A matrix like this, and this is obviously your B matrix. So there we have the state space form.